In this video, you will be presented with a .NET in-memory process memory dump of a W3 WP process consuming memory. It is expected that you have already downloaded and opened the appropriate memory dump file in WinDBG, and the MEX extension and the SOS extension matching the bitness of the memory dump process is loaded. Analyzing a memory dump in search of the reason for high memory dump consumption is one of the more challenging scenarios. In many cases, the reason is not discovered using a single command, rather a group of commands. Using the output of debugging commands can guide you to the root of the problem. Enter and execute the MEX list threads command. This can take a moment, so please be patient. The running threads have a high probability of being the cause or the consumer of the data stored in memory. Choose a few of the threads based on the highest execution times, for example, 22, 23, 32, 33. Change the focus to thread 33 and run the CLR stack2 command. On thread 33, you will notice a non-Microsoft code assembly. Take note of the assembly name and keep it in mind as clue number 1. Memory is mostly stored on what is called the heap. Enter and execute the SOS dump heap stat to view the objects which are consuming memory for the process. Notice that there are 10,700 system.char arrays consuming 1.8 gigabytes of memory. To drill further into what is contained in those arrays, enter and execute the dump heap of the method table. It is not always intuitively obvious from this point, and you will need to do some detective and investigative work. This can take some time, and it is also possible that you will not find anything of value here without a much deeper level of debugging. You do see a lot of objects of different sizes, mostly are 16 KB. To remove those from the output, you can enter and execute the following. Now you will see some objects with larger size of 71 megabytes. You would want to dump the object details of each of those objects and compare your results. For example, dump the last one with the address starting at 920. This will render information about the object containing that 71 megabytes of memory. The text next to the content is clue number 2, which may be helpful to a developer in determining where this data may be coming from and where in their code it is referenced. To find the root of that object, enter the following command, sos.gcroot, and then that object address. This returns the message showing the assembly, class, and method to which the object is linked. It's clue number 3. It matches the same as from clue number 1. Provide the findings from clue 1 through 3 to the party owning this assembly and have them investigate the code to determine the actions required to prevent it. Finally, but extremely important, is to recognize that memory dumps contain very sensitive information. Take extreme precautions and follow documented procedures for handling these files. Remove them from all devices once they are no longer needed.